All right, so for problem 2 of chemistry, it says, suppose a chemical reaction occurs where the concentration of a certain reactant A is constantly decreasing while the reaction takes place. A represents the concentration of reactant A at a certain time, T. The rate of the reaction can be written as the following first-order differential equation. So we have negative dA over dt is equal to K times A, where K is going to be the reaction constant and does not change throughout the course of the reaction. So part A asks us, after 8 seconds of the reaction, T is equal to 8, the relative concentration of A is 50% of its original value. What is the value of the reaction constant, K? So we're looking for K. So in order to find K, we're going to have to integrate the given differential equation, then plug in the given values. So here we have negative dA over dt is equal to K times A. And if we switch our dt, actually we'll do negative dt and our A, we'll get dA over A is equal to negative K dt. And so if we integrate both of these, we're going to get, on this side it's going to be natural log of A, and on this side we're going to get negative K T plus C. And to further simplify this, we can raise e to each of these values. So it's going to be e to the ln of A, which, as we know, we can say e to the ln of A is equal to e to the negative kt plus c. And we know that e to the ln of A is going to be equal to A. So A, and then with our exponential rules, we can simplify this and say e to the negative kt times e to the c. And the next thing I'm going to do is point out our assumption one more time. We're stated that A naught is A when t is equal to 0. So when t is equal to 0, it'll get rid of that first e term, and so A is equal to e to the c. Therefore, we can say that that is A naught. So A naught is equal to e to the c. And we can plug that back into our last equation. So we can say A is equal to A naught times e to get the negative kt. So now we can use this equation to find K based on the information provided in part A. So we already know that T is equal to 8 and A is equal to 0.5 A naught. So let's just write that out. So T is equal to 8 in this problem, and our A value, remember, is half what our initial concentration was. So now if we substitute those values, we will get the following. 0.5 A naught is equal to A naught times e to the negative 8. Okay? And from here, all you got to do is cancel these out, and then solve for the exponential there. And if you do that, it's going to leave us with k equaling 0.08664 about. And that's going to be our answer for part A. Now for part B, it says, by using the K value obtained in part A, when will the relative concentration of A reach 10% of its original value? And so this part, so part B, is actually much more simple. Using our value for K, all we got to do is solve for part B. So we can just plug and chug here, say 0.1, so 10% times A naught is equal to A naught times E to the negative 0.08664 times T. And here, all you got to do is move some stuff around and solve for T. And the answer here is going to be T is equal to 26.58 seconds.